We have been looking at solving quadratic equations, that is, equations of the form ax squared plus bx plus c is equal to 0, where a, b and c are any constants. And we've been looking at doing this in a variety of ways. We've looked at factorising, we've looked at completing the square. Well, now we're going to use the ideas of completing the square to look at this in a slightly different way. If we start with this equation, let us divide through by a, giving us x squared plus b over a x's plus c over a is equal to 0. And let's take that c over a onto the other side of the equation by subtracting it from both sides. So now we have negative c over a on the right hand side. And now let's complete the square on the left hand side. So we have x plus b over 2a, because that is half of b over a, half of the number of x's we had, squared. We'll now have to subtract that b over 2a squared. This is equal to negative c over a. Let's simplify this a little bit. By squaring this constant on the end, we will have b squared over 4a squared. All of this is equal to negative c over a. And now let's take that constant term we've just expanded to the other side of the equation. If we add b squared over 4a squared to both sides, we now have the right hand side is b squared over 4a squared, subtract c over a. Well, that expression on the right hand side could be combined into a single term, but we can't do that at the moment because we have two fractions which are not over a common denominator. So if we leave the first piece alone, leave that as b squared over 4a squared, but with the second piece, if we multiply top and bottom by 4a, the top of the fraction will become 4a times c, and the bottom of the fraction will become 4a times a, which is 4a squared. Now we've got this in a suitable form to combine into one fraction. That fraction being b squared subtract 4ac, all divided by 4a squared. Now we can take the square root of both sides. On the left hand side we have x plus b over 2a. On the right hand side we have the square root of the fraction from our previous line. Not forgetting that we have to consider both positive and negative versions. Simplifying the right hand side just a little bit. On the top, there is no easy way to write the square root of b squared minus 4ac, so we will just have to leave it like that. But the square root of 4a squared is 2a. We mustn't also forget we've still got this plus or minus. Now let's subtract that b over 2a from both sides, leaving us with x is negative b over 2a plus or minus the square root of b squared, subtract 4ac over 2a. And these two fractions on the right hand side are both over the same denominator, so we can write it as one fraction, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's just stop and think what we've got here. We started off with a completely general quadratic equation, ax squared plus bx plus c, and we have ended up with a formula which tells us what the values of x are. So using this formula is a way to solve any quadratic equation. Let us look at some examples. Let us use the quadratic formula to solve the equation x squared plus x subtract 1 is 0. So the quadratic formula tells us that x is negative b plus or minus b squared subtract 4ac rooted over 2a. In this case, b is 1, so negative b is negative 1, plus or minus b, which is 1, squared, subtract 4 times a, which is 1, times c, which is negative 1, all of that lives under a square root, divided by 2 times a, which is 1. So we have negative 1 plus or minus 1 squared is 1, negative 4 times 1 times negative 1 is plus 4, 2 times 1 is 2, and so the solutions are negative 1 plus or minus the square root of 5 divided by 2. It's always a nice idea to finish off by writing both of those answers down in their own right, so the solutions are negative 1 plus the square root of 5 divided by 2, and negative 1 subtract the square root of 5 divided by 2. Let's again use the quadratic formula to solve this equation. Quadratic formula, x is negative b plus or minus the square root of b squared subtract 4ac divided by 2a. In this case, b is negative 4. The negative of negative 4 is 4, plus or minus negative 4 squared, subtract 4 times a, how many x squareds have we got? Also 4, times c, the constant on the end, 1, all of that is square rooted, divided by 2a, 2 times 4. So we have 4 plus or minus negative 4 squared is 16, subtract 4 times 1 is 16, square rooted, divided by 2 times 4 is 8. Well, that means we've got 4 plus or minus 0 divided by 8. So whether we add or subtract the 0, we are going to get 4 over 8, we are going to get a half. So we have a quadratic equation which only has one solution. This will happen if the part under the square root comes to 0. This is sometimes described as saying that the quadratic equation has equal roots. We regard the plus 0 and the minus 0 as two different answers, they just happen to have the same value. Let's use the quadratic formula to solve this quadratic equation. So the quadratic formula, x is negative b plus or minus b squared subtract 4ac rooted divided by 2a. So b is negative 5, so the negative of negative 5 is 5, plus or minus b squared, so we have to take the negative 5 and square it, subtract 4 times a, which is 3, times c, which is 4, all of that lives under a square root, divided by 2a, 2 times 3, so we have 5, plus or minus negative 5 squared is 25, subtract 4 times 3 times 3, which is 48, rooted, divided by 2 times 3, which is 6. So we have 5 plus or minus the square root of negative 23 divided by 6, at which point we think, oh, there is a problem. We cannot take the square root of a negative number. Therefore, we're not going to get any answers to this. We have found a quadratic equation which has no solutions. And this will be the situation if the part under the square root is negative. Be aware that this is often described as a quadratic equation having no real solutions. This can look very confusing, particularly to people who are only studying maths rather than further maths, where it's a completely reasonable question to say, what do you mean real solutions? Are there some solutions which are not real? The answer to that question is actually yes, but that's not something that need to concern you if you're only doing the normal A-level course. You should just regard the situation where there are no solutions and no real solutions as effectively meaning the same thing.